Hi, my name is Henry Lee, and for the week 4 video, I'm going to talk about Transformers. As always, I'm going to base my presentation on the video made by 3 Blue, 1 Brown, uh, called Transformers. So, what is a Transformer? Well, you might have heard of ChatGPT and used it yourself even, but not many people know what the GPT at the end stands for. It stands for Generative Pre-trained Transformer. A transformer is a specific type of neural network that takes in a piece of text and predict what comes next in the passage. And this invention is the core invention behind the boom of AI. So how does it work? Well, we input like a string or like text, a passage to them to the AI, and it was split into pieces, and these pieces are called tokens. As you can see, the tokens don't necessarily have to be like one word. For example, it could also be like a punctuation, like a comma, or like split words, not an actual word, like CLEBE, and cleverest is split into three parts. They don't necessarily have to be complete words, and all of these are called tokens. Each of the token is then assigned like a vector column that somehow tells you the meaning of these words. And these words, or no, these columns come from the embedding matrix. And this matrix is a dictionary that contains all the possible words or like tokens and their vector columns or the values associated with them. And this dictionary is given to already. That's why the second or like the P in GPT is called pre-trained because they already created the table and assigned it to the values. When we input a string, we just compare the values, or you will look it up from this dictionary. Afterwards, all of these columns, are passed through an operator called attention block. And these attention blocks allows the vectors to communicate with each other and pass information back and forward. And this will update the values depending on the information shared. The reason why we do this is because words can have different meanings depending on the context. Each of these words will change the meaning depending on what the other words mean. For example, a computer model is different than a fashion model. And even though they're both models, the first words in them like changes their meaning. And that's why like if there's a word that could influence like another word, they pass the information and then like they update the values to reflect that. And from the attention block, it passes to a multi-layer perceptron, which is more familiar because this is the example that we watched on the previous videos about neural networks with a inverse recognition, handwritten digits recognition. And as you may know, like all of these values, or as you may remember, all of these values are used in a weighted sum to calculate the activation of like a node, all of these to this node, all of these to each node essentially. And this of value um, will change depending on the questions. So if all of these are calculated, or if it's the word queen and the values says that is activated and it says English, then it is right. But if queen is an English word and English is not right, it's not activated, it means that it is wrong. So we have to change the values so that it is activated. But like right now, it is correct. Like, is it English? Yes. Is it noun? Yes. Does it refer to a person? Maybe. Is it an amount? No. So it's not activated. So all all of the values that represent the word queen that will basically be we will use to answer the question. If if the question is wrong, or if the answer is wrong, the value will change accordingly. Oh no, not change accordingly. It will change the value so that it will activate, and afterwards it goes back and forward between attention block and multi-layer perceptron, attention block, multi-layer perceptron, attention block, multi-layer perceptron, until the meaning of the passage of the input is somehow baked into the last word. So that word will have all the context like inside of it, but through the values. The values are changed many times until the values are correct, or until the values um, somehow is able to represent this first part of this input. And then like from that column vector, we create a probability distribution to determine which word will likely appear next using a certain operation. I'm going to talk about that operation in a bit. That operator is called the softmax function. Vectors cannot represent probabilities because they are not limited to zeros and one. If we go back here, you can see that our vector values is like 9.2, 6.6, and sometimes they could even be negative, like negative 5.5 or negative 0.1, and they also cannot be calculate probability because the elements are up to one. Like if we go back, all of them are greater than one, so they will not add up to one. And that's why we use the softmax operation. By using the softmax operation, we are making it to the exponent of e. So the higher the value, the higher the closer the value to one, and the lowest value or like a negative, the lowest negative will be closer to zero when we uh, ex use exponents to the power of e, or not to the power e, with base e. And after that, we can calculate the sum and then like divide each of the values by that sum so that it all adds up to one. And that's how we're able to change these values into like a probability distribution of like which word will likely come next in the prediction and the probability distribution. In conclusion, transformers predict the next word in a sentence by first reading the user input. This means they split the text into pieces called tokens and match them to a given vector column. By default, a transformer should already have a dictionary of all the possible words and their meanings, and the meanings of the words is in the form of a vector column, like a list of values that tell you what the word means. These columns then pass to an attention block, which modifies their values depending on the values of the other columns. For example, if we have a token called life and another token that is called C, then the values of the column in life will change to reflect that you only mean life from the C or C life. So so it is more specific towards life. What kind of life? Sea, oh well, sea life. So that life means sea life. And then afterwards, the column goes through a multi-layer perceptron, which modifies the values depending on the question asked. For example, they will ask, is life a word, an English word? Is life a noun? Is life a country? And their value will change depending on the answer. So if it tells you that life is a country, then that's wrong. So you will have to modify the value of life so that it somehow tells you that it is not a country. It fails, so it fails the calculation that says that it is a country. Or vice versa. If it says a life is not a noun, you will have to change the values so that it evaluates to be um, not a noun. And we'll repeat these two processes over and over again until the word life has a very, very specific meaning. And once the last column or the last word has all the context, it will be able to predict the next word from a list of likely candidates. So what it means is that like the last word or that the last word that we inputted before the prediction, it will have all the context because of these two steps. And 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 since it already has all the context, it knows what the word will come next. So for example, if we have the last column or the last word as is the word is, then it will be able to predict the next word because it already know who from doing this, it already knows who's that person or who's the subject that we're talking about. So for if we were talking about dinosaur, predator, then like it already knows that it's a T-Rex. So from this like is it will be is the T-Rex because dinosaur, ferocious predator, and even though we don't tell it what it is, like is has all the context to predict that it is likely a T-Rex. Thank you.